Although I didn't invent the flame synthesis method, I became interested in this because of my PhD work on soot chemistry and see how soot is formed during the combustion process. To put things into context, I can first describe how soot is formed. During incomplete combustion processes, mainly it's in the gas phase chemical reactions, some polyaromatic hydrocarbons will form, such as benzene and naphthalene, and they will react with some other gaseous species and then form some dimers and later on become particles, mainly consist of carbon and a little bit of hydrogen there. We have the initial soot particles, and the particles will grow through both physical and chemical processes and then become nanomaterials. And later on, if we cannot fully oxidize them during the inside the flame, they will get emitted and form soot that becomes a particular matter that gets emitted to the environment. If you think about the whole process, we can see it's actually very similar to the flame synthesis method that are used in the industry. So we were thinking, instead of having an incomplete combustion, can we change the precursor that go into the reactor? And later on, we can synthesize some useful materials of interest. In this case, we're interested in metal oxide for catalysis, and we are interested in lithium-contained metal oxide so that they can be used as cathode materials for lithium-ion battery. So what we do is that we control what go into the system, and we control the combustion process by tailoring the chemical soup and temperature, and then we control the residence time and control the substrate so that we can control the morphology and composition of the material. And later on, we can assemble these materials together to be the cathode materials for lithium-ion batteries. It is a dedicated process. It utilizes the knowledge we obtain in fundamental combustion research. The process will be similar to the internal combustion engine. However, the goal would be different. In combustion engines, the goal is to generate hot gases to propel the engine and to give us torque and power. In flame synthesis, it will generate the chemical and the thermal environment for us to manufacture nanomaterials. Currently, the cathode materials for lithium battery is mainly synthesized using the co-precipitation method, where there's a lot of wet chemistry involved. And if we break down the cost of lithium-ion battery, we notice that there's about 40% cost on the cathode material side. And among that, about half of them comes from the raw material, half of them comes from the manufacturing processes. So we do think that by introducing the flame-based method, by speeding up and improving the scalability as well as the throughput of the synthesis method, we can bring down the cost on the manufacturing side.